Let's say we start from a plus x squared, alright? By direct multiplication, that is times a plus x, alright? Use the distributive property, alright? We expand as a plus x times a plus x times x, alright? This is called direct multiplication, alright? Which will give you a squared plus ax plus ax plus x squared, right? Hence you have a squared plus 2ax plus x squared, alright? Is it clear? That is called direct multiplication. So likewise for a plus x cubed, alright? You will have a plus x squared multiplied to a plus x, alright? Multiplied to a plus x. That will give you a squared plus 2ax plus x squared multiplied to a plus x. Okay? So once again you use the distributive property, you will obtain a cubed plus 3a squared x plus 3ax squared plus x cubed. Alright? Okay? So you continue multiply. A plus x to the power 4 will give you a power series like this. Alright? We arrange it in ascending power of x. Alright? That is a to the power 4 plus 4a cubed x, 6a squared, x squared, 4a x cubed, and x to the power 4. Right? Now let us consider the terms in this expansion. Alright? The terms without the coefficient. Without the coefficient, right? So you notice for a plus x to the power 1, you have two terms, right? Which is a and x, alright? And a plus x squared, there are three terms. The first term is a squared, followed by ax, followed by x squared, alright? And then for a plus x cubed, when you expand, there are four terms, right? The terms are a cubed, a squared, x plus ax squared plus x cubed, and so on. Alright? So, Rohani, do you observe any pattern in the terms for all these binomial expansion? Do you see any pattern? Pardon? That is the power of a, the powers of a decrease, right? The power of a decrease when the power of x increase. That is one pattern you observe, correct? In each expansion, you notice the power of a decrease each time by 1, correct? Each time by 1. And the power for x increase each time by 1. Also by 1, alright? What other pattern do you notice here? Lisa? What other pattern do you observe here? Besides the power of A increase and power of S decrease. Power of A decrease and power of X increase. Right? Besides that, what else do you notice?
Power of term increase.
Pardon?
Of term increase.
Power of terms increase. Number of terms increase. Besides that, what else? Rashid?
I think the sum up for the power is equal every term.
Correct. Very good. That is the sum of the powers in each term. You notice it's always equal to the power for a plus x. Correct? It's always equal to the power for a plus x. For example, a plus x to the power 4. First term, you have a to the power 4, right? Then the x term is x to the power 0, alright? So the sum of the two powers, you notice, is equal to 4, right? For second term, a cubed x, alright? The sum of the two powers is still 4, alright? It's always remain constant, alright? The sum of powers of each term is always equal to the power of the given binomial, alright? Is it clear? We take a look at the coefficients in the above expansion and arrange the coefficients in the form of a triangle like this, right? Another pattern is observed here. Okay, Baiti, what do you notice about the pattern in this triangle? What do you observe here? Yes, some good. You can see the coefficients in a particular row. All right, in a particular row is always equal to the sum of two consecutive terms in the previous row. Right? That is. Right. That is sum of these two will give you 2, right? Give you this coefficient, and sum of 1 and 3 will give you 4, right? 3 plus 3 give you 6. 3 plus 1, 4. All right. So beside this pattern, what else do you observe? Selena? What other pattern do you see here? Beside the sum, you also observe each row begins with 1 and also ends with 1. Correct? Each row begins with 1 and also ends with 1. Alright? So this triangle is called Pascal triangle, which can be used to determine the coefficient of the terms in a binomial expansion. Alright? For example, let's say we want to find the terms in the expansion of a plus x to the power 6. Alright? A plus x to the power 6. Therefore, we will expect the first term to be a to the power 6, right? A to the power 6, followed by a to the power 5, then x. Alright? These are the terms in the expansion. Alright? Then followed by a to the power 4, x squared, and so on. Alright? So coefficient of each term will be determined from here. Alright? The coefficient of each term will be determined from here. That is, you continue with this triangle. Start with 1. Alright? Start with 1, then followed by 6. Alright? Followed by 6, followed by 15, 15, then, 20, 15, 6, and then end with 1. Alright? End with 1. So these are the coefficients for the terms in the expansion of a plus x to the power 6. Alright? That is, you will get this. Alright? So the first term will be 1 times a to the power 6. Alright? Followed by 6. Right? 6 a to the power 5. Then x to the power 1. Alright? The power of a decreased by 1 each time. Alright? While the power of x increased by 1. Alright? So 6a to the power 5x, then plus